In section 4.2, we finally take a look at actually showing your triangles are congruent or figures are congruent and what that idea of figures being congruent means. One of the things you're going to have to show in your proofs and while you're doing this is where you're going to have to find measurements of angles, tell which measurements are congruent, and things like that. So in the opener, just a quick little reminder of some of the things we'll be looking for. One of the things we can look for with angles are your vertical angles. Remember, vertical angles are equal. So angle 3 and the 28 degrees, they will be equal because those are vertical angles. So angle 3, not 38, 28, sorry. Angle 3 is 28 degrees. Now, another angle I can work with. If you see your parallel lines under there, one of the things that we're going to be looking for in this chapter is we're going to be looking to see what do we call those alternate interior angles. So if I look at your alternate interior angles, it would be this one and this one. Angle 1 is going to be 46 degrees. Because this angle is congruent to this one. Because those are those alternate interior angles. Well, that leaves angles 2 and 4. As we talked about in 4.1, in your triangle, the three angles of a triangle are going to have to add up to 180 degrees. So right now you have 28 and 46. 28 and 46 gives you 74, which tells me angle 4 is 106 degrees then, because I had to get to my 180. Looking at your parallel lines again then, now if you look at your other transversal that's there, angle 2 and angle 4, they had to be equal angles also. So since angle 4 is 106, angle 2 is 106. All right, so there's the measurement of each of those angles. A couple things to keep in mind there as we talked about. Those vertical angles have to be equal. Your alternate interior angles have to be equal. When we get into working with our congruent figures mean that all of their pieces are going to be congruent. Now, one of the things you'll have to be on the lookout for, right, when I go through and start working on this chapter, is they're going to take our triangles and they're going to rotate them around. I can't just match up a left-hand side with a left-hand side or a bottom side with a bottom side. I need to look at the markings that are there. So angle B here, angle B has one marking on it. It will be congruent to angle P because it had one marking on it. Likewise, if I looked at side BA had two markings on it, it'll be congruent to side PO. Oops, not line. Side PO. Because it had two markings on it. So it's all about looking at the different markings that are there. Right. What congruent figures actually are? Congruent figures are when all the parts of one figure, meaning all of the angles and all of the sides, are congruent to the corresponding parts of another figure. Now, as usual in these videos, if you need to pause the video to finish copying down a definition, please do so. All right, so congruent figures are when all of your parts of one figure are congruent to those corresponding parts of another. When they talk about those corresponding parts, what we're actually talking about are their sides and their angles. Corresponding parts are a pair of sides or angles that have the same what we call relative position. What they mean by that same relative position is they're going to rotate these figures around. Right? We can't, when we talk about the same position, we're not talking the left side matches the left side. That's not always going to happen. But if you were to unrotate and unflip those figures, they would have the same what we call relative position. So corresponding parts are a pair of sides or angles that have the same relative position in two congruent or similar figures. We'll deal with similar figures down the road in chapter 6. So we're going to be looking at those angles and at our sides. Corresponding angles are two angles that have the same relative position. So looking at our angles here, that would be angle A and angle F because they both have one marking on them. Looking at angle B is actually with angle E. Even though angle B is on the bottom left, it's not going to match the bottom left. You got to look at the markings. Two markings goes with 2 markings. That's why it's B with E. And then angle C then will go with angle D. 3 markings with 3 markings. Right? That's how we tell what pieces match up. Same thing with your sides then. Corresponding sides are 2 sides that have the same relative position. All right, taking a look at example 1 that says, write a congruent statement for the triangles. Identify all of your pairs of congruent corresponding parts. What a congruency statement is. A congruency statement will say triangle blank is congruent to triangle blank. Right? The order here is going to make a very big difference. If you name your first triangle, they write down triangle ABC. Then I need to make sure my second triangle matches it. We can't just put it in a random order. We're not always going to just put it in alphabetical order. When we name our second triangle, we need to make sure we match up our pieces. So what did angle A match with? Angle A was a right angle. It matches with angle F. Angle B had 1 marking on it. Angle G has 1 marking on it. Angle C had 2 markings. Angle H has 2 markings. So there's that congruency statement. That triangle ABC is congruent to triangle FGH. And then we got to look at the corresponding angles and the corresponding sides. So our corresponding angles. In those corresponding angles, we can look at our measurements. Angle A was a right angle. Angle F was a right angle. And if you notice, A and F both came first. Angle B had a single marking on it. Angle G had the single marking on it. And if you notice, they both came second. Angle C had 2 markings on it. And angle H had 2 markings on it. And if you notice, they both came third in our statement. That order is important to us. Likewise, you can do the same thing with sides. Side AB. AB has 2 tick marks on it. So find a piece that had 2 tick marks on it. That would be side FG. So they're corresponding congruent pieces. Side BC had 1 tick mark, had 3 tick marks on it. It is congruent to side GH because it had 3 tick marks on it. Then we are missing side AC. Side AC has 1 tick mark on it. It is congruent to side FH because it has 1 tick mark on it. The other thing you could look at is in that congruency statement, it will tell us the sides that match up. AB goes first to second. It will match FH because it goes first to second. BC goes second to third. GH goes second to third. AC goes first to third. FH goes first to third. Right? Notice each one gave us our different set. Right? So that statement tells us a lot. And we're actually going to use that statement here in example 2. It says, in the diagram, figure QRST is congruent to figure WXYZ. First off, it says find the value of x. Well, there's 2 x's in my picture. I could look at WX, and I know WX. According to my statement, WX goes first to second. It will have to be congruent to QR. So WX, that's y minus x, will have to be equal to QR with 6. Unfortunately, I can't solve that equation right now because there are 2 variables in it. So we'll go look at our other x value. The other x comes in angle W. Angle W was the first piece in here. It has to match angle Q then because it's the first in this one. So angle W is equal to angle Q. That means 5x plus 5 will equal 65. To solve our equation, we subtract 5 from each side. 5x equals 60, and divide by 5. We get x to equal 12. If x is 12, I can come into my other equation and plug that 12 in. We now have y minus 12 equals 6. So we add 12 to each side. And we get y to equal 18. So there's your value of y and your value of x. So that is parts A and B. All right, brings us to our next idea. The next idea is known as your third angle theorem. And essentially all it is telling us is if I have two angles in each triangle to be congruent, maybe angle A is congruent to angle E. Maybe they're both 40 degrees. And C is congruent to D. Maybe they're both 60 degrees. Then right now I have 100 degrees tied up in angles A and C and 100 degrees in angles E and D. Well, that means that angle B would have to be 80 and angle F would also have to be 80. So if two angles are congruent to each other, your third set is going to have to be. That's why they call it your third angles theorem. That third set of angles will also have to be equal. And that's what our third angles theorem says. If two angles of one triangle are congruent to two angles of another, then our third set will also have to be. Take a look at example 4 then. In our picture, they want us to find the measure of angle V. So first off, looking at my angles that are here, I have angle STU is 66 degrees. It is congruent to angle VWU because it has one marking. So that angle would be 66 degrees. Looking at your vertical angles, angle SUT will be equal to angle VUW. So that angle is 44 degrees. I have two angles congruent to two angles. 66 with 66, the 44 with 44. If two angles are congruent to two angles, then your third set of angles would have to be congruent also. Angle S will be congruent to angle V. Well, if we can figure out one, we'll know both of them. Looking at your triangle then. You can look at either triangle here. I have 66 plus the 44 gives me 110 degrees. That tells me my missing piece, angle S, would be 70. If angle S is 70 degrees, then angle V is 70 degrees also. Which brings us to our last problem today, our last example. And we do get back into proofs in chapter 4. To prove two triangles are congruent, we had a plan for a proof here. What's nice about the proofs in chapter 4 is we can actually make a plan and talk about what we need to find. To show two triangles are congruent, we need to show two things. We need to show that there are three sets of congruent sides. We need to show there are three sets of congruent angles. So in a proof, we start with the same thing every time. It says given FH is congruent to JH and FG is congruent to JG. So FH with JH, FG with JG. As for my reason then, that is given. That gives us two of our sides. Overall, I need three. So we have one and two of them so far. That third set, the set that's missing, and we went over this back in chapter 2. That set that's missing, these two triangles share this side, HG. So we are actually going to be able to say that HG is congruent to HG. And there is a reason that we write down. And we're going to go over these properties one more time here later on in the period. But the idea that something is congruent to itself, that is your reflexive property. that just gave me my third set of angles. Or I'm sorry, my third set of sides. So I'm going to put my 3 tick marks on there. We have all 3 sets of sides. We've done part A. Part B says get our 3 sets of angles. If you look at the given information again, we are now told that angle FHG is congruent to angle JHG, and angle FGH is congruent to angle JGH. So out of my 3 sets of angles, right now we have 2 of them. As for the reason there, that is given. Now I need my third set of angles. My third set that we're looking at is angle F and angle J. As for why they would have to be congruent, we went over the idea earlier. If 2 angles are congruent to 2 angles, my third set's going to have to be. So since this angle is congruent to this one, and these sets down here are also congruent, I have 2 angles congruent to 2 angles. The third set will have to be. That is what is known as our third angle theorem. Once we show that we have all 3 sets of sides equal, and now all 3 sets of angles are equal, our triangles have to be congruent. So we name our 2 triangles to be congruent. As for your reason, this is your definition of congruent figures. This is what it means for figures to be congruent. All their sides are congruent. All of their angles are congruent. If you want to say congruent triangles, that's fine too. But that's your definition of your congruent figures. Now the last thing to go over, we're going to review those 3 properties. That reflexive property, symmetric property, and transitive property. They work for triangles also. So we can say that some triangle is congruent to itself. For any triangle ABC is congruent to triangle ABC. So if some figure shares 2 triangles, it'll be the same size in each. We had your symmetric property. That's what allows us to flip the sides that we're on. So if we're comparing triangle ABC to triangle DEF, you can also compare triangle DEF to ABC. So if ABC is congruent to DEF, then I can flip-flop the sides. Then triangle DEF is congruent to triangle ABC. Right? That's your symmetric property. It allows you to flip-flop those sides that you're on. And finally, there's your transitive property. That transitive property is what allows me to compare 3 different things. If triangle 1 is congruent to triangle 2, and triangle 2 is congruent to triangle 3, then there's another set of triangles that have to be. Triangle 1 will have to be congruent to triangle 3. Now, last thing I want to remind us of, there are 3 things that typically come up in these problems that allow me to get more information. 3 things to always look for when you're trying to find more sides or angles that have to be congruent. The first one, be on the lookout to see, do your 2 triangles share a side like they did in that example we did earlier? Because you can use the reflexive property to say that segment AB is congruent to segment AB. Another thing to keep a lookout for. Look to see, do you have those parallel lines like we did in the opener? Because those alternate interior angles have to be congruent. And finally, the third thing, which also came up in the opener, third place that they like to use a lot is your vertical angles. Because those vertical angles are always equal. Right? Those are 3 things to look for. And you'll see some of them in your homework tonight.